Hello friends, welcome back. Today we will understand a bit more about the Arduino board and its pin structure. This is the Arduino Uno R3 board and the pin diagram is also shown here. 14 digital input-output pins and 6 analog inputs along with some dedicated pins for power, serial communication and external inputs. Let's start with the analog pins side. The first pin here is marked as NC, which means not connected. Primarily, all of these pins on the board are connected to the microcontroller. You can find the circuit diagram on the Arduino website, but however, I think that level of details is not required for us at this moment. Coming back to the NC pin, while it might physically exist on the board, it doesn't have any internal connection to the other parts of the microcontroller or any other component on the board. So you cannot directly connect components or circuits to the NC pins as they will not function as intended. The second pin is the IOREF pin. This pin provides the voltage reference with which the microcontroller operates. A properly configured shield can read the IOREF pin voltage and select the appropriate power source or enable voltage translators on the outputs to work with the 5 volt or 3.3 volt. The third pin is the reset pin. This pin on the Arduino board is directly connected to the microcontroller's reset line. When grounded, it forces the microcontroller to restart its execution from the beginning of the uploaded code. There is another easy alternative to this process, the reset button. This button is physically connected to the reset pin. When pressed, it momentarily grounds the reset pin, triggering the hardware reset. The reset pin is the primary way to reset the board. In essence, the reset pin provides the mechanism for a hardware reset, while the reset button is a user-friendly way to initiate the reset by connecting the pin to the ground. We will use this functionality more frequently when we start working on complex projects. The 4, 5 and 8 pins are the power pins. The Arduino Uno R3 has both voltage pins like VIN 5 volt and 3.3 volt and a barrel jack for power, because they serve different purposes and offer flexibility in powering the board. The barrel jack is a common connector for supplying power to electronic devices. It's designed to accept a DC power supply with a specific voltage and current rating. In the case of Arduino Uno, it's typically used with a 7 to 12 volt DC adapter to power the board. The 5 volt and 3.3 volt pins provide regulated 5 volt and 3.3 volts power respectively for powering external devices or components. The Arduino's onboard voltage regulator converts the input voltage from the barrel jack or VIN into these stable voltages. The VIN input voltage pin is an input for an external power source like a battery or another DC adapter that isn't connected to the barrel jack. It bypasses the reverse polarity protection of the barrel jack, so users must ensure the correct polarity is used. The 6 and 7 are ground pins. The ground pins are essential for the Arduino board to measure and set any voltage. Basically, a voltage is the difference or potential between 2 points. Here, you take the ground and another point. So if everything in your circuit is connected to the same ground, all voltages can be compared and their value is relevant. Now let's spend some time in understanding analog pins. The Arduino Uno R3 board features 6 analog input pins labeled A0 to A5. These pins are capable of reading analog signals, which are continuous voltage levels, and converting them into digital values that the microcontroller can process. Think of a temperature sensor, a light sensor, or even a potentiometer like a volume knob. These devices give you values that change gradually, and analog pins can capture that information. Each analog pin is connected to the analog to digital converter ADC inside the Arduino. This ADC takes the analog signal, which is a voltage between 0 and 5 volts, and converts it into a digital value from 0 to 1023, that is 2 to the power 10 possibilities. So for example, 0 volts would be converted to digital value 0, and 2.5 volts would be converted to around 512, and 5 volts would be converted to digital value 1023. Here's a quick example to show you how you might use an analog pin in your code. This reads the analog voltage from pin A0 and prints it to the serial monitor. Here, although they are called analog input pins, some of them can also be used as digital input-output pins. For example, A0 can also be used as digital pin 14 if needed. Pretty flexible, right? Similarly, A4 pin on the Arduino Uno R3 is primarily used as analog input pin. However, it also serves as the I2C inter-integrated circuit data line. In I2C communication, A4 acts as a data line, allowing the Arduino to communicate with multiple devices using just 2 wires, serial data and serial clock. This is particularly useful for connecting sensors, displays and other peripherals that support I2C. Similar to A4, the A5 pin is also an analog input pin and serves as the I2C clock, the SCL. In this mode, A5 provides the clock signal necessary for synchronizing data transmission between the Arduino and connected devices. This ensures the data is sent and received in a coordinated manner. That's it for today. In the next video, we will understand the digital pins of the Arduino board.